Go, guys, go. Patrol, go. Telcom, go. Ginseng, go. Econ, go. Surgeon, go. Capcom, go. Continue CDI. All right, guys. Thanks for coming back to the garage and visiting us today. We're again, it's raining outside in beautiful British Columbia, so we are in the garage discussing crankshafts and strokers for the Type 4 engine. So consider this a primer on the subject at hand. Here I am back in the day with a Porsche 3.6 liter out of a 911 with a G50 transmission attached in my shop. I used to do a lot of the repair work on Porsches in Thunder Bay, Ontario, Canada. In those years, they did not have any real Porsche specialists, so I was the local go-to guy. And I did a lot of Volkswagen stuff too, air-cooled, just only air-cooled, really. And I'm proud to say that I worked at NASA, and check out my other videos on this channel, on the Stennis Space Center. I also worked at de Havilland Aircraft back in the crazy 80s and designed parts for the Dash 8, so do check out some of those videos as well. And don't forget to give us a like. Okay, as I said in a previous video, the 66 millimeter Type 4 914 or crankshaft for the 1.7 and 1.8 liter engine is very strong and a very good crankshaft and great up to 4,500 RPM. They're fast revving engines and lots of fun to drive. I really love them. They're super strong. They're forged German steel and they never break. And they got 55 millimeter main journals and 55 millimeter rod journals. They're great crankshafts, highly recommended. The 2 liter 71 millimeter stroke factory crankshaft looks very similar to the 66 millimeter stroke. Basically, they got the extra stroke by offset grinding the rod journals to get the extra stroke required. If you don't have a lot of money, this is the crankshaft that you're going to want to make a small stroker engine. This modification was accomplished by none other than Hans Metzger in order to develop the 2 liter engine for the 914. Hans was the father, the engineer who had designed the 911 air-cooled engine for Porsche. It's another great German steel forged strong crankshaft, perhaps not as strong as the 1.7, 1.8 because of the reduced main journal diameter, but perfectly suited for engine work up to 5,500 RPM. And it's non-counterweighted as well, but it can be counterweighted. Many of these are modified to add counterweights. Here you can see a counterweight crankshaft. You can see the counterweights on it. And this crankshaft is a modified 71 millimeter German crankshaft. This crankshaft was sent down to DPR, and also DeMello does the same thing in California where they weld counterweights to the original German crankshaft and machine them and do the finish machine as well. And they balance the crankshaft on a dynamic balancer. So it's a really high quality crankshaft, very strong and highly recommended. I used one 76 millimeter and a 78 from DeMello, the first one, and DPR, the second one. Amazing quality, amazing crankshafts. So, highly recommended again. Much better than the Chinese invasion. The engine shown here I built using 2 liter rods that were also sent down to Rimco to be lightened and balanced and clearance to suit the longer stroke. Please see my other video about that subject. It's well covered there. And of course, it does make the engines a little bit wider. So basically after that, any crankshaft that's just one solid billet that's machined out of a solid billet of material is most Mostly all of them are made in China. Um, Quality can vary. You're kind of, it's a little bit hit and miss. I mean, China makes all kinds of cranks for all the modern cars as well. So there's that. Um, what goes into a really good forged crank is double vacuum melted steel, where you basically melt the metal to form an ingot before it's turned into a billet by a drop hammer. The ingot is remelted, and the idea behind that is basically to ladle off the froth that floats to the top to get the impurities out of the metal. And that melt process is done twice on a high quality crankshaft, and on the cheaper units, it's only done, once in China. So the thing is, when you're looking at them, you can't really see that. They look nice and shiny and great. It's hard to know what quality. Um, Price, because they're also price competitive, they're pretty well all made by the same processes. So you don't really know unless you can do an eddy current inspection on them to look for inclusions and porosity and problems inside the material of the billet itself. You can't really tell by looking at it, unfortunately. So you're kind of taking your chances. I have used them. I used a 74 once that actually bent on me. Was that around? The engine was kind of running rough, and I did a V block check with a dial indicator on the center bearing journal, and found on the main, and found that it was out around quite a bit. So, I'm trying it again. The 80 millimeter that's pictured here, that's going to my 2316, is from SIP 1. It's also Chinese. I think it's 4340. It's a good material, but it's not the material. It's the fact that, you know, what's included inside the material, like voids, are, it doesn't matter. You can be the greatest material in the world, but if you got voids and porosity within the material, that weakens the material. And also, it's been known that Chinese 4340 is not to the same quality as, say, an American billet of the same. So I'm not saying not to use them, but I use them for lower horsepower engines, and I know a lot of the shops say, "Hey, we do an inspection on them and we look at them and so on." But unless they're doing real eddy current or radiography or some type of non-destructive testing on them, they don't really know either. They're just you know hoping for the best, let's say. Okay, so keep that in mind. Um, and I one time did have a problem with a welded crank too, where it cracked in the weld between the new weld and the old German steel crank. So nothing's perfect in this world. I remember they helped me out with that. They had an excellent warranty, and got me on my way pretty quick with a replacement unit. So it's a lot about the service that you get with a shop that you pick to work with, and or the company that you pick to work with. So keep that in mind when selecting a crankshaft. That's words to the wise. All kinds of strokes are available, and I'll rate them up on top there. And also, you can pick what type of rod you're going to be using based on, what you select for the rod journal size on the crankshaft that you're purchasing. For example, you can select a Chevy rod journal size of 2 inches, or you could select the 50 millimeter rod journal size, and that, determines what rods you can run on your crank. For example, one could pick a 50 millimeter rod journal diameter on the crank, or a Chevy rod journal diameter. Lots of Chevy rods available with a 22 millimeter piston pin diameter on the small end. These made for the Type 1 engine, but will also fit your modified Type 4. Also, there is several 50 millimeter rods available with a 22 millimeter pin as well that you can use in your Stroker Type 4. Here's a Keith Black piston from the Type 4 store that uses a 22 millimeter pin, so that way the pin is closer to the surface of the flat top of the piston, which makes it a bit lower down in the engine, therefore keeping the width of the engine a bit narrower, requiring less shims to build. So to recap, with a 78 millimeter crankshaft and rods, VW custom rods that are 5.325 inches long using a 22 millimeter pin and Keith Black 96 millimeter pistons, you'll get an engine that's going to be a bit narrower, pretty close to the stock length, in that you can use the original push rods and the original push rod tubes, and you're not going to have to shim it excessively to get you a compression ratio that makes sense. The stock 2-liter rods that can be modified in clearance, etc., the only thing with those rods is they use a 24 millimeter pin, so the lower compression height pistons aren't really available for those, which makes the engine wider, requiring more shims, as you saw in my previous video. Without going too crazy on shims, you could go to a 76 millimeter crankshaft with the 24 millimeter piston pin pistons, like the ones AA sells, with not too much difficulty and a little bit of clearancing. So that would be a recommended engine to keep the cost down, or the same thing with a 74 millimeter crank. I included a chart there that shows what can be done with different compression heights to achieve large bore, even larger bore engines, which of course are more expensive, with long stroke Nikasil cylinders and JE pistons. Alright, I think that just about covers it for today. My next video will likely be on cylinder heads, big bore heads. I included some pictures of some cars that I had with T4 power that I worked on and built, just to show what can be accomplished. Okay guys, thanks for dropping by at the Retro Garage, and we'll see you soon.